Welcome friends. In this new video we discuss about the derivative of function of two variable. Friends, you are familiar with the definition of how to find the derivative of function of one variable, but the process of finding the derivative of function of two variable is slightly different. The definition is the same. The treatment is also similar to that of the function of the one variable. We treat to find the derivative of the function of uh, one variable and find the derivative of function of two variable. So let me write the function of z equal to f of x comma y. Then here x and y are two independent variables and z is a dependent variable, and let us calculate the limit of f of a plus h comma b minus f of a comma b divided by h, and h tends to 0. If this limit exists, then we say that the function is a derivable with respect to x. Since you can see that there is a change in the values of the x variable, whereas the y variable remains same. Here the first value of y is b, second value in the second. There are two terms we have considered. We have considered the difference of these two terms where y have the same value, y equal to b. But here the slight change a plus h, and so we are taking the limit of the function where h tends to 0. That means the variable x is changing. Similarly, if we take the limit of f of a comma b plus k minus f of a comma b divided by k, and k tends to 0. If the limit is exists, then we say that the function is a derivable with respect to y. Here the function is a derivable. This is with respect to x, and this is with respect to y. And what is this? Here we are taking this change in the values of y only, whereas a remains same. So this is the derivative with respect to y. And here the friend, as we know, the function is of two variable. Therefore when we consider the derivative with respect to y, so it is not a complete derivative since there is another variable. So we denote this derivative by another notation, that is delta z by delta x. And here we are taking the derivative with respect to y, then we denote this by delta z by delta y. And another symbol is there, f suffix x, and here f suffix y. So these are the different symbols to use the derivative to denote the derivative of the functions. Similarly, for general case we can write this fx means derivative of f with respect to x. This is a partial derivative with respect to x, and it is a limit of f of x plus h comma y minus f of x comma y divided by h tends to 0. So when this limit is exist, it is called as a derivative, partial derivative with respect to x. Similarly, f suffix y, that is the partial derivative with respect to y, is equal to limit of f of x comma y plus k minus f of x comma y divided by k, where k tends to 0. So this is the definition of derivatives, how to find the derivatives with respect to x. So process is a very simple. So when we calculate the derivative with respect to x, keep y as a constant, and when we calculate the derivative with respect to y, keep x as a constant. Means treatment, when we take the derivative with respect to x, the treat y as a constant term, and as like while finding the derivative of constant, the same role here the variable y plays here when we calculate the derivative with respect to x. Similarly, when we calculate the derivative with respect to y, treat the variable x as a constant and then calculate the derivative with respect to y. So this is the simple meaning, and it is a simple way. In the simple way we can calculate the derivative of the function with respect to x and y. As there are two variables, as there are two independent variable x and y, we cannot take it as a complete derivative, since it is therefore we call it as a partial derivative. And similarly friends, you can see that if we have a function, simple function, suppose my f of x comma y equal to x square plus y square, it is a function of two variable. When we consider the derivative of this with respect to x, then the derivative of x square with respect to x is a 2x, whereas a derivative of y square with respect to x, y is a constant. I am treating this y as a constant, and we know the derivative of y is a 0. Similarly, when I will calculate the derivative with respect to x with respect to y, then I will treat this x square as a constant term, and the derivative of constant is a 0. So derivative of y square with respect to y, as like x, it will be 2y. Then you can see that this f of x y is again, means first derivative, partial derivative with respect to x, is again a function of x. Similarly, the first derivative of this the partial derivative of the function y, function f with respect to y, is a function of y again. So we can calculate the derivative once more with respect to x and y. That means when I would like to calculate the derivative of this the fx. This is another function. This is a function of x. So when we consider the derivative with respect to x, we denote this by another x. Okay, so this is the second derivative, and we can calculate the second derivative, and we get here 2. Okay, so this is the symbol to use the second derivative, or it is a delta 2z divided by delta x square, partial derivative with respect to x, and it is a second derivative. Similarly, when I would like to calculate the derivative with respect to y of this function, then I will get 0, since when I will treat with respect to y, I will treat this x as a constant term, and derivative of constant is a 0. Similarly, I can calculate the derivative of this fy with respect to y one more times, and I will get 2. So this is the second derivative, and I will write it as a delta 2z divided by delta y square. It is a not complete derivative, it is a partial derivative with respect to x and with respect to y. So friend, in this manner we can calculate the derivative of the function with respect to x and with respect to y. Let us see one problem of finding the derivatives of how to find the derivative of this. So first I will clear my screen, and then we take problem, and then we solve it, no, solve that problem, or so we find there. So let us consider, if u equal to x square into tan inverse of y divided by x minus y square into tan inverse of x divided by y, where x y not equal to 0. Then find delta 2 u delta x by delta y. So here I have to calculate the second derivative of this function. U is a function of two variables x and y. Here you can see that when we go from right to left, here it is given that I have to first find the derivative. I should first find the derivative with respect to y. Okay, so let us differentiate this with respect to y, and this differentiation is a partial differentiation, since it is a function of two variable. Okay, so when we calculate this derivative delta u by delta y, Now remember that when we calculate the derivative with respect to y, x is a constant. So this constant x square is a constant, and it is in multiplication of this function. So I will keep it as it is. Okay. Now let us take the derivative of this tan inverse. Tan inverse derivative, and we know that the derivative of tan inverse is 1 divided by 1 plus y divided by x square into derivative of this. Okay. So we apply the chain rule again. So rules are the same. There will be no difference in the rules. Remember this thing. And the derivative of y divided by x, as I have said, and I am consistently saying that the when we treat with respect to y, keep x as a constant. So 1 divided by x is a constant as it is, and derivative of y with respect to y is a 1. So friends, we get this derivative of the first term minus as it is. Now here y square and this tan inverse both are functions of y, so we apply the product rule. Let us call it as a first function and it is a second function. First we calculate the derivative of the first function. Derivative of y square with respect to y is a 2y, and second function as it is, we keep this tan inverse x divided by y as it is into minus first function as it is y square into derivative of tan inverse as we have calculated in the first term, it is same as 1 plus x divided by y whole square into my x is constant, so I will keep x as it is. Now calculate the derivative of 1 divided by y. When we calculate the one derivative of 1 divided by y, this will be minus 1 divided by y square. Okay friends, so so this x and this x square will get cancelled and we get here x into. Now let us simplify these terms. 1 divided by y square divided by x square. So we take here LCM and we get that 1 divided by x square plus y square divided by x square minus. Now you can see that here minus 2y as it is into tan inverse of x divided by y. There is no need to simplify this term. This is in simplified form, already is in simplified form. So this y square and this y square get cancelled, this minus minus become plus, and we get x divided by y square plus x square divided by y square. Okay. Now this x square is in the denominator, so here this x square and x get cancelled and this x will go into the numerator and we get x divided by x square plus y square plus here this y square will go into the numerator and we get x divided by y square divided by no, there is a no here we get x square will go into the numerator and we get here x into x square, that is a x cube. So here we can see that here we get xy square and here y square plus x square, and this term will be as it is 2y into tan inverse of x divided by y. Okay. Now you can see that here from this numerator of these two terms we can take x square, x as a common term. Taking x since the denominator is the same, x square plus y square, x square plus y square, so instead of 2 we write the addition of the numerator and we take x common from the numerator and we get x square plus y square divided by x square plus y square minus 2y into tan inverse of x divided by y. X square plus y square, x square plus y square will be cancelled and we get x minus 2y into tan inverse of x divided by y. So this is the derivative of u with respect to y. Now the derivative of u, this first derivative with respect to y, since we have to calculate the second derivative. So let us differentiate this once again with respect to x now. Now this is delta u by delta x delta y. Now remember that when we differentiate this with respect to x, y is a constant. So derivative of this x with respect to x is a 1 minus this 2y, 2 and y both are constant for x, when we differentiate with respect to x. So keep it as it is, and derivative of tan inverse is 1 divided by 1 plus x divided by y whole square into x divided by y. X divided by y, derivative of this, as we know, y is constant. So 1 by y is a constant term as it is, and derivative of x is 1, equal to 1 minus this y, and this y get cancelled, minus 2 divided by 1 plus here x square divided by y square, equal to 1 minus 2 divided by y square plus x square divided by y square. Okay, now transfer this y square here, equal to 1 minus 2y square divided by x square plus y square. Again we can simplify this, we can multiply and take the LCM of this, x square plus y square minus 2y square whole divided by x square plus y square. So from this y square and minus 2y square, we can write this as a minus y square. So final answer we get that this derivative delta 2u by delta x into delta y equal to x square minus y square divided by x square plus y square. So friend, in this manner you can calculate the derivative, partial derivative. So remember that once thing you have to take into consideration while calculating the derivative, and it is a most important when you calculate the derivative, is that when you differentiate with respect to x, keep y as a, treat y as a constant. When we differentiate with respect to y, when we differentiate with respect to y, keep treat x as a constant. So if you take into consideration this, or if you remember this thing while you are calculating the partial derivative, your answer will be never wrong. Okay friends, thank you for watching this